Hi, my name is Chloe and I am a mechanical and mechatronic engineering student. In this video, I will show you my process of creating an arcade game, specifically this arcade game. First, here is a quick video of my final project. The components required to build and create the game include coloured LEDs, the Cyclone 4 board, which includes the game button, reset button, clock frequency, 7-segment display and pins, and a breadboard where the 8 LEDs and Cyclone board are connected through wires and 1 kilo ohm resistors. This is a picture of my main schematic so that you may visualise the different components of the Cyclone game. So how the game works is that there's initially 3 remote inputs for the system, including the clock, the hard restart and the game button. When the clock is powered, it sends a direct input to the game button's debouncer, the clock divider for the SSD display, and clock divider for the LED function. The restart is also connected to every part of the circuit so that when it is pressed, it may restart the entire board and schematic. The LED portion of the schematic is fed by the clock of the Cyclone 4 board, which feeds into a clock divider as I mentioned earlier. This slows down the clock pulse of 50 MHz to approximately 2.969 Hz, which inherently slows the activation of each LED. To create this clock divider, I used 24 D flip-flops connected in series with a single output. The output of the clock divider then feeds into both the 1 to 8 demultiplexer and 3-bit sequencer. The 3-bit sequencer provides the 3 selection inputs for the 1 to 8 demultiplexer, which powers each individual LED in a sequence at individual times. The LED outputs are connected to 8 individual pins to allow for the wiring of this section. This is how the board is physically wired up. For the game button portion of the schematic, the button is connected to a debouncer, which is also connected to the clock and factory reset button on the board. The debouncer steadies the output when the button is pressed, preventing fluctuation in the output so that there is no unwanted outputs. The debouncer output is fed into a 2-input AND gate, which then is connected to the score counter. Once the button is activated at the same time as the LED that has been chosen as the winning LED, allows for an input to be fed into the counter. The button is also connected to an XOR gate with the winning LED that feeds into the fail buzzer. This is so that if the button or LED are activated individually, the game will be lost by sending an input to the buzzer. This is a picture of the button portion of the schematic. The AND gate previously mentioned in the button portion of the schematic feeds into the score counter block. The score block contains 4 4-bit BCD ripple counters with an AND gate that joins them, so a reset is sent to the current counter and an input to the next counter when a binary output of 1010 is outputted from the counter. The score block has 16 outputs that then feed into a 16:4 multiplexer. This 16:4 multiplexer is the selecting block that selects the number to be displayed on the Cyclone 4's 7-segment display and is made from 4 4:1 multiplexers. These 4 outputs are then fed into a hexadecimal to 7-segment display schematic so that the board can display the number. The 7-segment display on the Cyclone 4 board, however, only allows for 1 digit on the display to be powered at any instant. This means that a 2 to 4 decoder is needed. The 2 to 4 decoder selects which digit is to be activated at any instant of time. The selection inputs for the 2 to 4 decoder will also be the selection inputs for the 16:4 multiplexer, so that the correct number may be displayed on the correct digit at the right instant. The selection lines are fed by a 2-bit sequencer, which is powered by the main clock and slowed by a clock divider containing 16 D flip-flops to divide the 50 MHz frequency of the board to approximately 760 Hz, so so that the display may appear as if all 4 digits are being powered at the same time, but not fast enough to damage the display. This is a picture of the scoreboard portion of the schematic.